Today we're going to be taking a look at one of the, really the capstones of the statistics course that we're going to be studying, and that is hypothesis testing. Hypothesis testing is used all over the world by scientists as a way to analyze data to determine, are their results significant enough to make a particular claim? We're going to walk through the process in this first video, just kind of getting a feel for how we're going to structure a hypothesis test, and then later we'll take a look at calculating hypothesis testing for one population means and proportions. So for us to get started, one of the first things we want to talk about is the rare event rule for statistics. So it says if under a given assumption the probability of a particular event is extremely small, we conclude that that assumption was false. Here's an example of that. If I wake up in the morning and I think it's going to rain, and then I look at my Weather Channel app and I see that the percent chance of rain was 0%. Well, I had thought, or I had hypothesized that it was going to rain, but I looked online and I found the probability of rain was very, very low. So what can I assume about my original assumption that it was going to rain? My assumption was false. It's just a basic understanding of that. So to set up a null and alternative hypothesis, this is going to be the first step for hypothesis testing. The null hypothesis, which we denote as H with a little 0, is a statement that the value of a population parameter is equal to some claimed value. The null hypothesis will always contain an equal sign. The alternative hypothesis, denoted H1, you might also see it denoted H with a little a, is the statement that the parameter value has a symbol that differs from the null hypothesis, so it is not going to be an equal sign. The alternative hypothesis will use one of the following symbols. It will have either a less than, a greater than, a less than, or a not equal to symbol. This is a new symbol for us, but it's how you say that something is not equal to a value. So we're going to get a little practice setting up the null and alternative hypothesis now. The first one says the claim is that less than 50% of adults say that cloning of humans should be allowed. So we can see that we are working with a proportion here because I am provided a percentage. It is saying less than 50%. We know this means that we're going to be working with proportions. We are making a claim about a population that less than 50% of all adults, right? So remember, the null hypothesis is always going to contain an equal sign. So the null hypothesis will be that it is 50%. But that wasn't our claim. We can see right here that our claim was that less than 50%. So the alternative hypothesis is going to be P is less than 0.50. If it helps you to put the 0.50, that's fine. 0.50 or 0.5 will work either way. We do want to, however, mark this one as the claim. The reason that it's important to mark your claim is when we get into the process of doing hypothesis tests, which one is the claim is going to determine the type of language that you use in your conclusion. The next one says the mean head circumference of all 2-month-old human babies is 40 centimeters. We can see here that we are working with means, so we are going to use mu because we are working with, we're making a claim about a population mean. Now remember that the H0 always has an equal sign, so that it is 40 centimeters. Now let's think about what the alternative is. In this claim, did I say greater than or less than at all? I didn't. It says that the head circumference is 40 centimeters. Is means equals, right? So my claim is going to be the H0 value this time. So then how do I state the alternative hypothesis? Well, we're going to use the not equal sign because it either is 40 centimeters, which was our claim, or the alternative is that it's not 40 centimeters. The next one says 30% of all federal drug arrests are drug related. We're going to be working with a P here because I see that percentage, which is presenting me a proportion. The H0 is going to always be an equal sign, so equals 0.30. We want to write that percentage as a decimal. So then if the claim is that it Does it say less than or greater than here? No, it's claiming that 30%, correct? So again, for our alternative, just like the last problem, it either is 30% or it is not 30%. So my claim value is the H0. Next one, the mean internal body temperature of healthy adults is less than 98.6. They are talking about a mean here, so we know we're going to use the mu. The value that we're claiming is 98.6. Remember, our null hypothesis will always have an equal sign. So, was that our claim? Was it our claim that it is 98%? No. When we take a look at the claim, it says less than 98.6. So my alternative hypothesis here, which will be my claim, is that the mean is less than 98.6. And one more, a couple more. Among smokers who try to quit by using the nicotine patch, over half of them are smoking again within 1 year. We are working with a proportion here. And it's going to be over half, right? So P, we're going to use P is equal to, well, what is half? Half would be 50% again, right? So P equals 0.50 is our null hypothesis. The alternative hypothesis, since we are claiming that over half its P is greater than 0.50. Why don't you hit pause in the video and try this next one. So see if you can write the mean weight of all adult black bears is more than 200. See if you can, oh, I forgot to mark the claim in these last ones. Sorry, going back. This one would be the claim, and this one would be the claim. All right, try it for number 6. So in number 6, it says the mean weight of all black bears is more than 200. Again, the null hypothesis is going to get an equal sign, equals 200, but that's not the claim. It's more than 200, so the alternative is going to be greater than 200, and that one will be the claim value.